Hey guys, today I have a really fun experiment. I have a lightweight 3D printed airplane and a PLA airplane. These are completely identical. All electronics, all the receivers and everything are the exact same in both airplanes. Now we're going to take you back to the workbench. I'm going to tell you about some differences between the two airplanes, more than just the material, because there are some differences with printing lightweight PLA and PLA, and you cannot print every single airplane by every single company that's out there with lightweight PLA. So I want to talk to you guys a little bit more about that and explain to you the difference between the two materials, and we're going to do some strength testing. And stick around till the end of the video because we're going to throw these on a scale and check the weight, and we're going to take them out here and fly them in the desert and see how well the lightweight flies versus the PLA. So check this out, guys. Okay, so the first thing I want to talk to you guys about is the printing process with lightweight PLA. You know, a common thing out there that people are saying that, you know, lightweight PLA is really hard material to work with. Because of how the PLA works, once it gets through the extruder and it reaches above 230 degrees Celsius, it starts to foam. And so once that foaming reaction starts, when the extruder has to move places, you can't eliminate the stringing. So I actually did some stringing tests here. So I ran a whole bunch of tests, you know, turned up the retraction settings like pretty much as max as I could get them with this printer on a direct drive printer. And, you know, this is as good a stringing as I could get as this last setup. Now, here comes why Eclipson particularly works very well with lightweight PLA. So Eclipson has designed a technique for printing the parts that involves no retraction. So I've had people make comments on my videos like, how do you get your wings to look so good with no retraction? Well, it's Eclipson's design of how they actually print and design the wing that there's no retraction. So as long as you set the Z-seam location in the correct place and you set up all your extra settings, there's no retractions at all. So therefore, you can use lightweight PLA. You don't have to worry about any of the stringing or anything like that. You can basically just have your retraction settings set off. I mean, you don't even hardly need them on there at all. And it'll come out with a perfect quality piece every single time. And so if we take a closer look at this, you'll see that I have the part kind of rotated over, and then I have the Z-seam set on the front axis right here, and it's set to front and expose. So it's set right here, so it goes all the way around, and then it just gets to this edge, and then it moves up the next layer and keeps going. So you can see there that there's no stringing at all, it never retracts. That's why, you know, Eclipson particularly works really well with lightweight PLA, because there's no retraction. And if you look a little closer at the drive motor on this printer, you can see that it's just continually rotating. It never, you know, goes in reverse. It just keeps, you know, pressing the material into the print. It never actually retracts ever. So this is with a direct drive printer, and I use this, I printed all this stuff on my Bowden tube printers too, and it just like works perfectly. I mean, there's no, you know, inconsistency at all. It keeps a continuous pressure at the Bowden tube the whole time. You never have to worry about all this retraction kind of settings. Okay, now I've got a 3D lab print wing from the Cessna 152 that I did, and you can see the difference between the Eclipson wing and this wing. See the inside of the wing, it's got stringing all inside here. You can see the driving motor, how it's retracting, priming, priming. The stringing inside the wing isn't completely bad. I mean, you can still print it. It doesn't add a ton of weight to have that stringing in there. It'll work just fine, but the inside of the wing is going to look pretty bad. And then you hold it up to the light, you can definitely see like the stringing on the inside of the wing. But where it comes, you know, a problem too is if you're going to print off like two parts like this, you know, these are two parts printed together, and you can see that, you know, this is your result. You've got stringing all between the parts there. You got to clean all this up now, and there's not a way to eliminate that. With the wings, you know, the extruder usually stays within the wing, it's fine, but when you're printing a fuselage part, and like if you have a hollow center where the battery tray and all that kind of stuff's at, well, you're going to get stringing all in that area, so you got to clean all that out, and it's kind of a pain. So let's take a little bit closer look in Kira. So with the Eclipson part, you can see I have the travel line set on, and there's no blue lines anywhere on this part except for on the very, very top where you print the tabs to assemble the wings together. There are some travel lines there. So that's the only travel lines and retraction and priming settings on the Eclipson wings, on the very, very last few layers. Now you can see for the 3D lab print wing, the entire center of the wing is covered in blue lines. That's because it's traveling all over on the inside of there. To sum it all up, basically As long as you're printing an Eclipson plane, your PLA and your lightweight PLA are going to print identical. There's going to be no difference between difficulty as far as printing lightweight PLA or printing PLA. Now when it comes to other planes, when you're going to print, if you're going to print, say like I'm going to print a 3D lab print 152 out that I already did, like you know, you're kind of getting into uncharted territory at that point. You know, you're kind of in testing phase there because it hasn't been tested. See, so Eclipson actually is the only company out there that has designed all of their airplanes to work with lightweight PLA. So the designer basically has to design the plane to be available to work with lightweight PLA, and if they haven't, then, you know, like I said, you're in kind of uncharted territory. It may or may not work. So taking a little closer look at the Model Cs, they're completely identical. All the pieces are the same. I have all the same receivers, motors, servos, everything's set up the same. The lightweight PLA version is just painted red. That's one disadvantage to lightweight PLA is it only comes in white or black, and the PLA, you get that any color you want. So another disadvantage of it is the cost. So you only get lightweight PLA from Color Fab in the Netherlands, so depending on where you're going to ship it to, that can cost some money, and the product itself is like twice as much as regular PLA. But the difference is too, you have to think about is you're printing PLA at 100% flow rates, and you're printing lightweight PLA at 53% flow rate. So you're actually going to be able to print more airplanes out of the lightweight PLA version than the PLA version. Something with Eclipson planes that is nice, the continuous printing that it doesn't do any retraction. The parts print really fast. So like in this whole plane with the wing and everything, it's like 48 hours of continuous printing, whereas anything else is like hundreds of hours of printing. I mean, you could print just one section of wing is like 12 hours or something like that with other companies. So with that minimum movement of the extruder, it saves a ton of time and just way easier to print. So that's something to keep in mind also. Okay, so the next thing that we're gonna do is a little bit of a strength test. So I have two parts. I have a PLA and a lightweight PLA part. So I don't have any fancy tools or anything I can really like test the strength of this with, or put it on some tests and give you an exact number for like what the strength is. But I'm just gonna try to break these. I'm gonna try to break the skin with my finger, and I'm gonna try to break this in half. The other thing is like the finish. If you look at the finish on this is a nice, smooth, glossy finish. The lightweight PLA is kind of like a fuzzy kind of finish to it. It's not like perfectly smooth. It's not like glossy. It's like a flat white kind of. So that's a little bit of the thing, is just the look of it. So we're gonna try to break these. Definitely you can just feel the surface of this is a lot softer than this. But something with the strength of this that you do need to keep in mind is Eclipson has designed all their airplanes to be printed with lightweight PLA. And so their wing design, if you look inside the wing, the structure inside is completely solid. There's no slots or holes inside the rib sections in the wing or the fuselage. So that's designed to work with lightweight PLA because they know that the lightweight PLA is not as strong. So they actually reinforce the material more in a lightweight PLA airplane. But in the end of it all saves weight anyways, because the lightweight PLA is so light. So, but then if you print the same part out of regular PLA, it still is fully filled on the inside of the wing, and it's very strong, but it's heavy also. So first we'll weigh these. So for the lightweight PLA, we have 19 grams, and for the PLA, we have 43 grams. So that's the same part. And then you can see the inside, how there is a hole here for the servos. And then here, there's no like slots here, and same with the lightweight PLA version. So if you look at a competitor wing, this is like a 3D lab print, inside of a wing, and it's just completely open. Now this is a really bad print. This is a pretty old piece that I have, but you can see just the difference in structure on the inside of the wing. So what I'm gonna try to do here is actually break the skin of this. So let's try to do it on the lightweight PLA version first. So you can see kind of, here's a rib section kind of between here. I'm going to try to actually break this with my finger. So just without much pressure there, I just cracked it. Now let's try it with the PLA version. So pushing way harder than the other one, and it's like bending here. I can't actually get it to break. Wow, that skin is strong. It's very strong. There we go, I got it to break. There we go. So yeah, it's way stronger than the lightweight PLA. And then turning it like this way, twisting it, you know, it's very strong, you know, versus like this one. Definitely, you can twist that and break it. Now let's try to actually break it in half. So let me see this. So right here is actually 2 layers thick here. So like this is 2 layers thick here. So this is kind of works as like a spar in there, how strong that is. So I'm gonna try to just break it this way. Let me try it with the lightweight PLA version first. Yeah, there we go. So yeah, it broke right there at the seam. It was pretty strong. Let's try to do it with the PLA version now. There we go. Now we got that to break. So it's definitely a lot stronger, you know, than the lightweight PLA. But you know, that was, you know, you don't usually do that with your regular wing. Okay, so definitely the PLA wins the strength test for sure. Lightweight PLA is definitely not as strong. Okay, the other difference between these 2 airplanes are the tires. So on the tires for the PLA version, I used just regular TPU. And for the lightweight PLA, I used Verisure TPU by Colorfab. So this is also another material that works just the same as the lightweight PLA, where it has a foaming reaction and makes the part way more lightweight than regular TPU. The other thing that's nice about it is it's a lot squishier, so it has a lot more like shock absorption on the landing. So for like this bush plane where the tires are kind of oversized, you know, this Verisure TPU definitely helps with cutting down the total flying weight for the airplane. Now as far as assembling goes for the 2 airplanes, they're pretty much identical other than a few parts. So as far as like for these 2 airplanes, in the tail section, for this airplane, there's no carbon rods inside of the rear part of the fuselage. But in the lightweight PLA version, Eclipson recommends to have, you know, carbon rods for this tail portion here. So that's one difference between the 2 models. And then there are a few things that are printed out of regular PLA, like for the lightweight PLA version. Like we'll start like the spinner here, the accent pieces for the exhaust pipes, the parts for the landing gear here are regular PLA, these wing support pieces are PLA, the servo mounts for the wing and for the fuselage, and then like the rims for the tires are regular PLA. So there are a few parts that are just regular PLA within the lightweight PLA model to keep it strong. So, you know, parts that are, you know, or like the, you know, the engine mount is printed out of PETG or ABS for the temperature resistance. So there are a few differences like that. Whereas the PLA model, you can just print like all the parts out of PLA. I mean, the whole fuselage printed out. These are all printed out PLA. All the wing, you know, everything's printed out in PLA. So that's one difference there. So the assembly process is equally easy for lightweight PLA or PLA. The printing process is the same, like I said, for each one, as long as you're doing the Eclipson airplanes. So let's throw the wings on them, put the batteries in there, and let's get it ready to fly weight, and then we're going to be taking these out to the desert and trying to fly them. Okay, so about 680 grams for the lightweight PLA version. Okay, so there we go. We have both the planes completed, PLA and lightweight PLA. This one is 210 grams more than this lightweight PLA airplane. So we're gonna take them out here and see how they fly, and we're gonna test these out and see which one flies better and see which one we can get flying slower. So let's, we're gonna try this lightweight PLA plane first, and then we'll go with the PLA airplane. So let's go ahead and get these ready. Okay, we have it flying on the lightweight PLA airplane. It's flying really well. I put in some flaps and you can get it flying really slow and just really good flying little plane. So let's get this one on the ground. Okay, so that went really well with the lightweight PLA version. The plane flies really well, it flies nice and slow. So let's get the PLA version set up and we'll try that one out. Okay, so that's a little bit of a problem. The CG is a little bit aft compared to the lightweight PLA version, so I might have to add just a little bit of weight in that nose to get the CG set right. Alright, so we have the PLA version up. This doesn't fly nearly as good as the lightweight PLA version. It takes a lot more ground roll to get off the ground. I'm having to have a lot more power in to keep it up in the air. And it's still flying okay though. You know, and the CG was a little bit of a problem. I think the CG is still a little bit aft, so I'm just being kind of cautious with it. Don't want to stall it really, because I think it's a little tail heavy. Alright guys, this is a little bit of a crazy landing on that one, but it worked okay. So since with the lightweight or the PLA version is, you know, definitely was a handful to keep in the air. The biggest problem I think was the motor setup I have for it. I have a 980 kV motor in here, and that's what I have in the lightweight PLA version, and it works really, really well for that. Just because I'm trying to go for that slower flight kind of characteristic. So definitely for this airplane, it's way faster. You have to keep this plane flying faster. So it needs like a higher kV motor in it. It needs like a maybe 1400 kV motor and not like a slow flight prop on here. then you could fly this thing faster and it would be better, but it's way heavier. I mean, you can just tell like how much heavier this plane is than the lightweight PLA airplane. And the CG was a problem getting that set, so I had to add quite a bit of weight in the front, and I already have a pretty big battery in here anyways as it is, so that was a problem getting the CG set. So definitely having like an aft CG, kind of underpowered, it flew really hard, and I got in a couple situations where I almost stalled it, almost crashed it, and the landing was really bad because it wasn't really controlled. So okay, you guys, to sum up this video, if you guys can print out a lightweight PLA, I definitely recommend it. It flew way better than the PLA version. You know, like I said earlier, not all airplanes can be printed out of lightweight PLA, so make sure you check, you know, the website and make sure they can be printed out of lightweight PLA or somebody's done it before. But all of the Eclipson airplanes are okay to print in lightweight PLA. Definitely would recommend printing all of the Eclipson planes out of lightweight PLA. PLA, you know, it's just way heavier. I mean, I have them all ready to fly right now, and this is just so much heavier. You got to have a lot more power than I had in here, so make sure you have a little bit more power set up in this thing, and you can also do it in PLA. Thank you so much for watching this video, and we'll see you guys in the next build.